I've just switched on the mic. Okay. Hello, everyone. Welcome to the session. If you can hear me, just type in yes on the Q&A, and if you can see the welcome slide, which shows the information about today's session and the code to join online for the session. To join the whiteboard, let me know if you are able to join that as well. While you're waiting, please join in. I'll just give a couple of minutes for a number of people to actually. Thanks, Grace, for joining on the whiteboard. We'll give a couple of more minutes for them to join. Okay. Right, 2 more minutes and we'll start the session. Thanks for joining. Make sure that you are logged into the whiteboard session by scanning the QR code. It should let you in. Right, about to begin. Right, welcome to this session for the combined science higher tier chemistry paper. In this session, I'm going to go through the exam paper for June 2022. Make sure you're logged into the whiteboard so that you can write the answers. If you're using a desktop or a laptop, you can have the Teams and the whiteboard web page side by side so that you can either write using your mouse, or if you are using a tablet, you should be able to write your answers, or you can simply type in the answers. Okay. Question 1. This question is about salts. Green copper carbonate and sulfuric acid can be used to produce blue copper sulfate crystals. So they have given you green copper carbonate, sulfuric acid to produce blue copper sulfate crystals. The excess copper carbonate is added to sulfuric acid. So they are adding excess copper carbonate. Give 3 observations that you would make. I'll give you about 1.5 minutes. Can you type in your answers on the whiteboard? Let's see if you can work out some of the observations that you would make. That's okay, Rai. So make sure you answer the question. Excess copper carbonate is added to the sulfuric acid. So give 3 observations you would make while you're doing it. So there's a number of observations that you can make. I will list all the available options during this practice. I think this is one of the core practicals for you. So the copper carbonate dissolves. So you could say when you're adding the excess copper carbonate is a black powder. So it dissolves, and you could also say blue solution is formed, produces bubbles. You could also say the color of the sulfuric acid. So that's an observation as well. So colorless solution at the start. Since you're adding excess copper carbonate, you could say some copper carbonate is left undissolved at the bottom. Any of those will be accepted answers. Moving on to the next question. How can the excess copper carbonate be removed? And question 1.3, the solution of the pH of the solution changes during the reaction. What is the pH of the solution at the end of the reaction? And 1.4, copper carbonate and sulfuric acid react to produce copper sulfate. What type of reaction is this? Can you write the answers on the whiteboard? I'll give you about 1.5 minutes. Yes, Grace, so far you're right. Try and use a better word, Josh. Well done, Daniela. Yeah, Anaya. Matthew, so far right. So how can the excess copper carbonate be removed? By filtration. Was correct. Because the copper carbonate was a solid, it's a black solid powder. So you need to use filtration. The pH of the solution changes during the reaction. What is the pH of the solution at the end of the reaction? So at the start, you had sulfuric acid and you are adding it to copper, adding the copper carbonate. I have been writing it as CuO. I'm sorry, CuCO3. That's copper carbonate. Now, this is acidic. So at the end of the reaction, it should be a pH of 7 because all the acid should be neutralized. So what is the type of reaction is neutralization. Neutralization. Next question. Ammonium nitrate is a salt. Figure 1 shows the maximum mass of ammonium nitrate that can dissolve in 100 centimeter cube of water at different temperatures. So here on the graph, you have temperature on the x-axis. It starts at 0 and goes up to 100. And the maximum mass of ammonium nitrate that can dissolve in 100 centimeter cube of water. And as you can see at 0, it starts somewhere about 20 and it increases all the way up to about 100, up to about 110 or 20, no, 104 grams. Right. The student adds ammonium nitrate to water at 80 degrees Celsius until no more dissolves. The student cools 100 centimeter cube of this solution at ammonium nitrate from 80 to 20 degrees to produce crystals of ammonium nitrate. Determine the mass of ammonium nitrate that crystallizes on cooling 100 centimeter cube of the solution from 80 to 20. I'll give you 2 minutes, see if you can work out the answer for this question. You will need to use the graph. I'll leave the graph as it is without changing the slide view. You should be able to get it within a range of plus or minus 5. Okay, so you will need to find out the mass of ammonium nitrate that is dissolved at 80 degrees Celsius at the start. So you would draw a line on the graph from 80 degrees Celsius to the top of the line and across. Now remember, there's 5 boxes between 0 and 10 on the y-axis. So each box is 2. So as you can see, this is just over the first box. So at 80 degrees Celsius, the mass of ammonium nitrate that is dissolved is 83 grams. And at 20 degrees Celsius, it's 32 grams. So 1 mark for each of those values. So when you're cooling it from 80 degrees to 20, you would get the difference in the mass, which is 51 grams. So each of those points is the mark for this question. Next question. This question is about electrolysis. Figure 2 shows the apparatus used to investigate the electrolysis of potassium sulfate solution. So you have here a power supply, which is usually supplying DC current, and you have inert electrodes here, which is usually made up of carbon or platinum. It could be a platinum wire, or it could be graphite, which is usually carbon. So on one side you have hydrogen being produced, and on the other side you have oxygen being produced. You have potassium sulfate solution with 50 centimeter cube over those electrodes. Potassium sulfate contains K plus ions and SO4 2 minus ions. What is the formula of potassium sulfate? Can you write the answer on the whiteboard if it is 1, 2, 3, or 4? Yeah, Grace, you got it right. Yes, Daniel, you got it right. Well done. Yes, well done. So the correct answer is K2SO4. So number 2 was correct. And if you're wondering how we're actually getting this, you need to look at the charge balance. So when it forms a compound, you will need 2 K plus ions to balance off the 2 minus ions. So this charge should be balanced by this when it forms a compound. What are the volumes of gases collected in the electrolysis experiment? So you need to look at the diagram again. I'll move back to show you the volume of hydrogen and the volume of oxygen. Can you write your answers on the whiteboard? 30 seconds. Grace, have a look at it again. So when you're looking for the volume of oxygen and hydrogen, you need to look at the values from the top over here. So from there, that's where you take 0 as and measure it downwards, not from here. This because this is water. So oxygen, that's 10 plus 5, that's 15, and that's 10, 20 mark, and then your 30 mark. So hydrogen was 30 centimeter cube, and the oxygen is 15 centimeter cube. So Oxygen was 15 and hydrogen is 30. A student made the following hypothesis. The volumes of gases collected in this electrolysis experiment are in the same ratio as hydrogen atoms to oxygen atoms in a water molecule. Explained how the volumes of gases collected in this experiment in figure 2 support the student's hypothesis. So how does this volume ratio? So you're looking at the ratio of hydrogen atoms to oxygen. Hydrogen to oxygen is the same ratio as the number of atoms. Can you write your answers on the whiteboard? 30 seconds. Yeah, you're well done. You're getting it right, all of you. So if I look at the formula for water, H2O. So here I have hydrogen and oxygen. That's 2 atoms of hydrogen for every atom of oxygen. When I look at the volume of hydrogen and oxygen, here in terms of volume, hydrogen is 30 is to 15. So that's 2 is to 1. So explain, you can show this working and you can say that when you work out the ratio of the volume, it is 2 to 1 and the atom ratio is also 2 to 1. So you get 1 mark for making reference to the correct formula of hydrogen, water, and for working out the correct ratio for the volume ratio. Next question. The experiment is repeated 4 times. The volumes of oxygen collected in the 4 experiments are 6 centimeter cube, 9 centimeter cube, 10, and 11. The mean volume of oxygen collected in the 4 experiment is 9 centimeter cube. The measure of uncertainty is the range for a set of measurements about the mean. What is the measure of uncertainty in the 4 experiments? So which one would this be? 30 seconds. See if you can give me the answer. Well done. It is number 3. Question 2.6. The potassium sulfate solution has 0.86 grams of potassium sulfate dissolved in 25 centimeter cube of water. Calculate the mass of potassium sulfate needed to make 1 dm cube of the solution. So I'll give you a couple of minutes because it's usually a high level question trying to work out the mass. So I'll give you 2 minutes. See if you can work out the mass of potassium sulfate needed to make 1 dm cube or decimeter cube of the solution. Well done, Matthew. Yeah, you're getting it there. Hi, Shahid. Let's work it out. So the potassium sulfate solution has 0.86 grams of potassium sulfate dissolved in 25 centimeter cube of water. Calculate the mass of potassium sulfate needed to make 1 decimeter cube. So conversion. So you will need to convert the 25 centimeter cube into decimeter cube. So if you divide that by 1,000, you will get 0.025 decimeter cube, right? So you convert the volume, that is going to give you 1 mark, and the concentration 0.86 grams. Right? If you divide that by the volume 0.025, that should give you 34.4 grams per dm cube. Now, although I'm saying I'm calculating the concentration, I'm calculating it for 1 decimeter cube. So the question is asking calculate the mass of potassium sulfate needed to make 1 decimeter cube. So the answer is still 34.4. Well done. Most of you did get it right. Next question. Right. It's basically the same question. Question 3. This is going to take a little bit of time, and I would like you to try it. I'll give you enough time. Plan an investigation to find the order of reactivity of 3 metals. So the question is asking you to plan. So you will need a method. So because it's a 6-mark question, make sure that you have written the question in a nice logical manner using scientific understanding. Plan an investigation to to find the order of reactivity of 3 metals, you should use the temperature change. So when each metal reacts with hydrochloric acid, so you're reacting the metal with the hydrochloric acid, and you need to use temperature change as part of your investigation. So I'll give you a couple of minutes for you to see if you can write it in bullet points. Don't worry about going into detail. So if it helps, draw a diagram. I'll give you 4 minutes. So in order to get the 6 marks, make sure that your method is clear and it should lead to the production of a valid outcome. All key steps should be identified and it should be logically sequenced. Overall, I'm getting some really good answers. Well done. Make sure you're clearly identifying any control variables. You don't have to state it, but think about any variables, the control variables, how you're measuring the dependent variable. So here's a simple setup of the experiment that you could use. Have the acid in a test tube of known volume, 30 centimeter cube. They are asking you to find the order of reactivity for 3 metals, so you could label it as A, B, C if you don't know what the metals are, and you can make reference to these metals as A, B, and C in your answer as well. And you would use a thermometer to measure the temperature change. And in order to control, right, so the control variables should be mass of metals and physical state, right? Let's say powder, right? Remember the surface area of these metals, if one of them is powdered, the other one is in lumps, and it will affect the rate of reaction. So, and that can cause the temperature change that you're measuring to be affected. Although it's not going to affect that much, if you are measuring it, the temperature change over a given period of time, then that definitely will affect it. So let's start the points. So first point, add known volume of acid to boiling tube, let's say 30 centimeter cube, and measure the starting temperature using a thermometer. So in this first sentence, I have given a lot of information. So you're referring to the volume of acid, and you have given the volume of acid that you're going to measure. You're going to add, and you are stating that you're going to measure the starting temperature, which is important if you want to find the temperature change. And you're also giving the equipment that you're going to use. Now, I've said boiling tube. I think here better it would be a polystyrene cup, as a couple of you have actually said in the whiteboard answer. Well done. So, right now, if you're using a boiling tube, you can actually insulate it. The main reason is to using a polystyrene cup is you don't want any of the heat that is generated during the chemical reaction to escape or to be transferred to the surrounding. So add a known mass of metal to acid, let's say 5 grams. And here I'm going to allow it for all of them to actually to react and then to dissolve. So allow the metal to completely react, meaning to dissolve, and record the highest temperature reached. So the reason I'm preferring this method is maybe one of the metal, because you're looking for the order of reactivity. So naturally, one of the metal is going to be more reactive than the other one. So, but you can actually use the other method, which is to find the temperature for a given reached for a given amount of time. So let's say like 5 minutes. Allow the metal to completely react and record the highest temperature reached. Right? Record and find the temperature change. The next 2 points is going to be important. Repeat for each metal to get an average temperature change. Right? And final point, repeat for all 3 metals. And one last point, right? the metal with the highest temperature change would be the most reactive. That should give you the 6 marks. There are a couple of other points that you can actually write as well. The concentration of acid needs to be the same as well. And where you're saying 5 grams, you could say using a weighing scale. So according to the marking scheme, they usually ask for you to show that you have mentioned how you're actually measuring the temperature change as well. So here we have said find the temperature change, and you can say final minus initial temperature. That's how you would find the temperature change. Right. Let's move on to the next question. Question number 4. This question is about group 7 elements. What are the group 7 elements known as, and why do group 7 elements react in similar ways? I'll give you a minute or so. Can you write the answer for both these questions in the whiteboard, please? Well done, Aya. Yes, now you're getting it, Daniela. Yes, you can. Yes, Hannah. Got that. So group 7 elements are known as the halogens. Why do group 7 elements react in similar ways? Right? The main reason is since they all have the same number of electrons in the outer shell. Right? Now, since they're in group 7, they will have 7 electrons in the outer shell. Remember, just to look at the electron configuration as a revision, right? You have fluorine, which has 9 electrons. So you'd have 2 electrons in the first shell and 7 electrons in the second shell. And chlorine, which has an atomic number of 17, will have 17 electrons altogether. So it has 2, 8, and then 7. So because they both have 7 electrons in the outer shell, they react very similarly. Now, you don't generally need to know the electron configuration for bromine and for the rest of them, but you do need to know the electron configuration for fluorine and chlorine. Figure 4.3 of figure 3 shows the structure of a molecule of chlorine oxide. What is the molecular formula of the chlorine oxide molecule in figure 3? Can you write the answers on the whiteboard? Well done, Matthew. You're smashing it. Yeah, you can. Yeah. So how do you work out the molecular formula? Now, here, as you can see, what they have given you is the structure of a molecule. So this is what you call a structural formula. So that's chlorine, and this is oxygen. So all of these are oxygen atoms, and you have chlorine as well. So in the molecular formula, it tells you the type of atoms that it is actually made up of. So you have chlorine and oxygen, and it also tells you the number of atoms that is found in each molecule. So you have 1, 2 chlorine, and you have 1, 2, 3, 4, 5, 6, 7 atoms of oxygen. That's how you work out the molecular formula of chlorine oxide. Next question. Figure 4 shows the melting points of some group 7 elements. You have the melting point in the y-axis that's starting at 0, and iodine is above 0. Astatine is also above 0, and you have fluorine, which appears to be either 0 or they haven't given you, and chlorine, which is below 0, and bromine is also below 0. So the melting point of fluorine is minus 220. Complete figure 4. You should complete the scale on the y-axis and draw the bar for the melting point of fluorine. So minus 220. So there it needs to be going down. Now, if you look at each of these 5 boxes, it's increasing by 50. So this would be minus 100, minus 150, minus 200, and minus 250. In order for you to write this, that is going to give you 1 mark, and 220. So fluorine, if I start there, and the box is going to be between those 2 points, because here they've left 2 boxes on either side of this bar, and it needs to go up to 220. So each of those boxes is 10. So it needs to go right up to here. Sorry. Sorry, for some reason my pen doesn't seem to want to draw a straight line. So make sure that you actually draw a straight line. Make sure you take a ruler and draw a straight line. Please don't draw it like this. I'm using a graphics tablet pen like this, which is finding it difficult to draw straight lines at the moment. So as long as this bar reaches up to this second point, I think you should get a mark according to the marking scheme. That's the main thing that they're looking for. Next question. I put the same bar graph on this side because for this question you'll need to refer back to the bar graph. Explain the trend. So explain, you need to say why. And when they say trend, they're referring to a pattern in the melting points of the group 7 elements. I'll give you 2 minutes. See if you can write 3 to 4 points. So explain the trend. So describe what the trend is. Remember, this was minus 250 and this was minus 200. So we drew a bar like that. Write your answers on the mini whiteboard, please. I'll give you a minute. If you're struggling, think what is happening to the melting point, write that down. Then write down why it's happening. And generally that the reason for that actually carries 2 marks. Well done. Those who are writing the answers you're getting right. So I had only 1 mark so far. Try and write 3 points. 10 more seconds and I'll tell you what the answer is. Right. So if I was to draw a straight line, sorry, from fluorine all the way up to astatine. Oh dear, please. Right. So generally, the melting point is actually increasing along this line. So your first point should be explain the trend. So you can either say why, or you can actually say what the trend is and then give a reason. So I'll start off with the trend. The boiling point increases down the group. So fluorine is your first element in group 7, and then your second, third, fourth, and fifth. So this is down the group. Second point, we are giving a reason why the boiling point actually increases down the group. Right? The size of the molecules increases down the group. Right? Remember, fluorine has only 9 protons, so it's one of the smallest. It is the smallest atom in this group. So astatine is quite big because it has a bigger atomic mass and it has more electrons as well. So the size of the molecules increases down the group, right? So the intermolecular forces also increases down the group, right? So referring to melting, so the intermolecular forces also increases down the group. So more energy is needed to overcome these forces. So as you go further down the group, you will need more energy to break the bonds or the intermolecular forces that keeps these atoms together. So next question. 4.6. What is the state symbol of bromine at minus 50? The state symbol. So for that, you will need to have a look at bromine in the bar graph. So if you look at bromine, what is it at minus 50? So remember, when you are looking at the bar graph for this, right, which is minus 5, no, minus 10, because there's only 5 boxes here. So the melting point of bromine is minus 10. So what would be the state at minus 50? And the next question, evaporation and boiling occur at the surface of bromine at its boiling point. Name one more process that happens at the surface of bromine at its boiling point. I'll give you a minute to write down the answer and then we'll move on for a 10-minute break. State one more process. For 4.7, you need to name one more process that happens at the surface of bromine at its boiling point. Yes, a couple of mistakes in one or two of yours. So if it's melting at -50, once it melts, it would turn into a liquid. So the melting point of bromine was, sorry, remember the melting point of bromine was -10 degrees Celsius. So at -10 degrees, it is melting to become a liquid. At minus, it should be a solid. And 4.7, evaporation and boiling occur at the surface of the bromine at its boiling point. Name one more process that happens at the surface of bromine at its boiling point. It should be condensation. Right. So I'm going to move on to question 5. And before we do that, let's take a 10-minute break and we'll come back in 10 minutes. So the time now is 7 minutes past 5. So we will join back in 10 minutes. So that'll be at 5:17. Right. I'll see you guys soon. OK, let's start back on the session. We have another 40 minutes to go through the 3 questions, so I'm going to go slightly faster. Question 5. This question is about structure and bonding. Figure 5 represents the part of a carbon molecule. Name the type of carbon molecule in figure 5. And then suggest one property that makes carbon molecule in figure 5 useful in nanotechnology. 30 seconds. Can you write the answers for me, please, on the whiteboard? Try and use another word rather than nanotube, because they're making reference to carbon technology here. Since I've come out of the PowerPoint, you might have actually looked at the diagram that I have attached. So these are nanotubes. Now, in the marking scheme, what they're expecting you to write is fullerene, right? Fullerene, or you could say carbon nanotube. Nanotube, both of these will be accepted. So you can say fullerene. Now, here it says fullerene, but this is actually a circular structure. This is actually called Buckminster fullerene. Please do not write Buckminster fullerene because you will not get a mark for that. So just one property that makes the carbon molecule in figure 5 useful in nanotechnology. You have a couple of properties. So first one, can conduct heat. 2, conducts electricity. And you could also say has high tensile strength. And finally, you could also say has a large surface area to volume ratio. In medicine, it can actually trap medicine as well, molecules of medicine, which is also useful. Next question. An alloy of aluminium contains small amounts of other metals. So explain why other metals are added to aluminium. Right. So if you're making an alloy, it's not just one metal. An alloy is a mixture of two or three metals. So why are other metals added to aluminium? I'll give you a minute to see if you can write a couple of points. If you can draw a diagram, it'll also be easy in your exam. It just gets your points across much better. So yeah, you are getting the answers, right? Those of you who are writing the answers. So having another metal is probably not the best diagram, right? So in a normal metal, you will have just aluminium. If it's on its own, all the atoms of aluminium have the same size, so they're arranged in a nice repeated pattern. When you introduce a metal atom from a different metal, it kind of distorts this arrangement, and that's the key thing, right? So first point, atoms of other metal would have a different size. This distorts the layers of aluminium, preventing them from sliding over each other. And third point, this makes the alloy harder. So 4 marks. So 1 mark for this point, 1 mark for this, 1 mark to say that it stops it from sliding over each other, and 1 mark to say that it makes it harder. Hence, you're explaining to say harder or stronger as well. Figure 6 represents part of the structure of a polymer. So you have a polymer chain. So these are the individual units are called monomers. Compare the bonding within the chain with the forces between the chains in this polymer. So each of these monomers has a bonding, these lines, and there is forces of attraction between the chains. So that's what they're asking. Compare the bonding within the chain with the forces between the chains in this polymer. So write down about the forces within the chain first and then between the chains. Give you 30 seconds. Write the answers on the mini whiteboard, please. So within the chain, there is covalent bonding. Right? So, in a polymer, these are usually covalent compounds. So there's covalent bonding, which is stronger. Between the chains, there is weak intermolecular forces, which are, we've already said it's weak. Right? So to identify the different type of bonding, the covalent bonding and the intermolecular bonding, each of them carries a mark. And for you to say which one is stronger and which one is weaker, it carries the third mark. Next point. Next question. Question number 6. This question is about hydrogen chloride and hydrochloric acid. Complete the dot and cross diagram to represent the bonding in hydrogen chloride on figure 7. Use dots and crosses to represent the electrons. You should only show the electrons in the outer shell. I'll give you 30 seconds. See if you can draw the electrons in the outer shell for hydrogen chloride to show the bonding. Yeah, you're getting it right. Well done, guys. So hydrogen has got one electron in its outer shell, which is actually shared. So if I draw the dot for the hydrogen and the cross for the chlorine atom, chlorine is in group 7, so it should have 7 electrons in the outer shell, and it shares 1 electron with chlorine. Make sure you only have a pair of electrons between in this shared area, and the rest of the 6 electrons in chlorine. And if you draw it in pairs, it makes it easy to count, and you avoid making mistakes. Otherwise, you might add more than the number of electrons that you need. 6.2. Hydrogen chloride dissolves in water to produce hydrochloric acid. Hydrochloric acid is a strong acid. What is meant by the term strong acid? Next question. See if you can answer both of them on the whiteboard. Describe how magnesium can be used to distinguish between a strong acid and a weak acid of the same concentration. So a strong acid completely ionizes in aqueous solutions. What does ionize or dissociates? You can use the word dissociates as well, meaning that when you have hydrochloric acid, it simply breaks down or into Cl- and H+ ions when it's in water. So you have H+ ions. Now, if it's a weak acid like ethanoic acid, you're not going to have all of the molecules of ethanoic acid breaking down into forming a positive and the negative ion or the H+ ions. How can you use magnesium to distinguish between a strong acid and a weak acid? Now, right, because it's the same concentration, right, at the same length or mass of magnesium, step to the same volume of each acid. So the length has to be the same and the volume of the acid needs to be the same. The only thing that should be different, and the concentration is already the same. So the only thing that should be different is the strength of the acid. So, right, in the stronger acid, the magnesium would dissolve faster. So it would completely dissolve much faster than in a weak acid. Next question. The concentration of hydrochloric acid is increased by a factor of 100. What is the change in pH? So if you increase the concentration of the acid by a factor of 100, what would be the change in pH? I'll give you 30 seconds. It's 2 marks. And remember, for those 2 marks, you need to say what happens to the overall pH and by how much. That's where you're going to get the 2 marks. So the pH decreases, right, by 2. Each of these points is 1 mark. Next question. Right, I've shown you the pH level. So the pH is here 10 to the power 1, 10 to the power 2, and so on. It increases up to 10 to the power 14. 6.5. Ethene and hydrogen chloride react to produce chloroethane. The displayed formula equation for the reaction is that's your ethene, that's hydrogen chloride, and it's forming chloroethane. The reaction is exothermic. In the reaction, the energy released forming new bonds is 56 kilojoules per mole greater than the energy needed to break the existing bonds. Table 1 shows some bond energies. Calculate the bond energy X. So calculate the value of this. So how do you actually calculate it? I'll give you 3 minutes. See if you can work out the bond energy X. I'll give you a little bit of help to make a start. Okay, right. Carbon, hydrogen, 430. I just want to check. Yeah, and carbon chlorine is 339. So if you work out the total of these, you should get 2750, and here you should get 2083. Remember, this is what we are trying to actually find out. So energy released is equal to the bonds made minus the bonds broken. So the overall energy change is 56 equals 2750 minus 2083 plus the carbon-carbon double bond. And this should give you an overall value of 611 kilojoules per mole. Next question, last question. Question number 7. This question is about elements and compounds. Now, this information that you're seeing here, I've added more information, right? This doesn't appear in your exam paper. So this is the exam paper question. Figure 8 shows the reactivity series. Give the method and conditions used to extract metal Y, right? And here, as you can see, you've got carbon here, right? Now, the metal between magnesium and carbon is aluminium, which any of these metals, sodium, calcium, magnesium, and aluminium, needs to be extracted by electrolysis. So give the method. The method is going to be electrolysis, and the condition. What is the condition for electrolysis? The metal needs to be molten. Now, when I say metal, I'm referring to the ore, metal ore. Needs to be molten or in liquid state, so that during electrolysis, the ions can move. So remember, right? So next question. Sodium reacts with titanium chloride to produce titanium. Complete the equation. You should balance the equation. And then the reaction between sodium and titanium chloride is a redox reaction. Write a half equation to show that sodium is oxidized in this reaction. So I'll give you 2 minutes. See if you can write the answers for me on the whiteboard, please. Let's have a look at the answers. Well done, Aya. Let's see. Okay, let's go through this. So sodium reacts with titanium chloride to produce titanium. So it should have titanium as one of the products. So there. So the rest of the ions, sodium and the chloride, forms NaCl. There's 4 chlorines here. So in order to balance the chlorine, I would add 4 there. That makes 4 sodium as well. So I would add 4 in front of the sodium. That would give the 2 marks. Write a half equation to show that sodium is oxidized. So you're referring to the sodium. So sodium is starting off as a solid. It's changing to an ion, which is Na plus, right? That would mean there's an electron that is left behind, or it's removed from sodium to form the sodium ion. Next question. I believe this is the last question. No, there is 2 parts to it. Oh, there's a couple of more. Right. 108 grams of aluminium reacts with 1.2 kilogram of copper chloride to produce copper. The equation for the reaction is 2 aluminium reacting with 3 copper chloride to form 3 copper and 2 moles of aluminium chloride. Calculate the maximum mass of copper produced in grams. So they want the answer in grams here. You should determine the limiting reactant. I'll give you 5 minutes for you to work out the answer for this. See if you can start writing the answers on the on the whiteboard, please. Looks like a lot of you are struggling with this question. I'll give you some help while you're doing this. What you have here is 2 moles of aluminium. They have given you the relative atomic mass. So find the total mass of aluminium that is reacting and the total mass of copper chloride that is reacting and the total mass of copper that is being produced. So you can use these values. 27. Copper chloride is 134.5 and copper is 63.5. Now, you don't have to be bothered about the mass of aluminium chloride that is also being produced, so we are not going to use this number. So 2 times 27 is reacting with 3 times 134.5 to produce 3 times 100. No, the copper is 63, so 63.5. If you work out the mass, it is 54 grams of copper is reacting with 403.5 grams of copper chloride to give you 190.5 grams of just copper. So according to the question, you are adding 108 grams of aluminium. Why did I make a mistake here? So aluminium, right? So when you're adding 108 grams of aluminium, give a couple of more minutes for some of you because you're trying to answer the question. So the next step would be to use these numbers. So the reacting masses are the ratios. So if 54 grams of copper aluminium is actually reacting with copper chloride, 108 grams would react with, this is the key, 807, right? You're literally doubling it by 2, right? So if you double this, this also doubles by 2. And the amount of copper that is being produced will also double by 2, which is 381 grams. So you're only making 381 grams of copper. So which the limiting reactant. So you're adding actually 1.21 kilogram, which is 1,210 grams of copper chloride, which means that is in excess. So this is in excess, which means the aluminium is the limiting reactant. So there isn't enough aluminium for it to react. The mass of copper that is being produced is 381 grams. Next question. Sodium metal and sodium chloride are both able to conduct electricity. Describe how sodium metal conducts electricity and explain how sodium chloride can conduct electricity. I'll give you another couple of minutes. We'll probably overrun this session by about 5 to 6 minutes, which is fine. I'll give you 2 minutes. See if you can write a couple of points on the whiteboard for me, please, for this question. Well done, Aya. Remember, the second question is asking explain how, and the first question is also asking describe how. I've given you a little bit of help to see sodium chloride. Sodium metal, as I said, it has just sodium metal ions. Now sodium is a metal, it's in group 1. So it has one free electron to form an ion. So Na or sodium metal has delocalized free electrons, which can carry a charge through the metal. 7.6. Explain how sodium chloride can conduct electricity. Explain how. So sodium chloride has a very robust structure and it has sodium and chlorine ions. Now, if it's in a solid state, it's not going to conduct any electricity. Hence, I've given you the diagram for this. So, right, it can only conduct electricity in molten or when dissolved in water. This allows the ions to move freely to carry a charge. So here in a solid state, they are fixed, they are attracted to each other, so that it's not going to move. But when you heat it to make it into a molten state, you're going to get Na plus ions and Cl minus ions. If you dissolve in water, it also forms Na plus and minus ions. So it's the ionic bonding is broken down. Next question. Oops, actually, that's we finished the session. I was thinking there was one more question. Okay, right. Thank you for joining the session today. I know it was a little bit slow because I wanted to allow everyone to try and participate in the lesson as much as possible. So it's not very fast. I'm trying to aim and go through one question paper. Now, if you're interested in actually joining the session for tomorrow, I'm running a session for biology paper 2 tomorrow. And then on Monday, because it's a bank holiday, I'm running the paper 2 for chemistry on Monday, same time from 4 to 6. If you want to sign up, visit the website on www.tutorboost.co.uk. You can also follow us on Instagram, Facebook, and we also have a YouTube channel. The YouTube channel is still being developed, so you're not going to find a lot of videos, but we'll try and add the videos from these sessions as we go on. So if you missed any of it, you should be able to find the YouTube videos, this session on the YouTube video. And follow us on Instagram or Facebook. We always keep adding more information. And if you have any queries, please message us. Thanks for joining the session. And hopefully I'll see you soon tomorrow. And if you get a chance, please do leave a review on Trustpilot. It helps us. And if you think sessions can be improved and what you found difficult, let us know or message us either on Facebook or just email back to us. And if you can accommodate your needs, we'll be happy to do it. So thank you, and shall see you soon tomorrow for the biology session. Josh, I'm sorry if you're asking for the questions. We will email you the exam paper with the notes that we used. And the YouTube video, we'll try and upload this session on your YouTube video as much as soon as possible. All right, thank you guys. Let us know if you need anything. We'll happily help. See you tomorrow.